स्टूडेंट्स, लाइन कोडिंग की स्कीम्स हम लोग डिस्कस कर रहे हैं और डिस्कशन happened around unipolar and some polar schemes. We'll carry on with that discussion. Students, we have discussed unipolar NRZ and we have discussed polar NRZ RZ. We are going to talk about the biphase, which includes Manchester and differential Manchester now. Students, हमने different disadvantages देखे थे of both non-return to zero and return to zero polar schemes. Students, we are going to talk about polar biphase. There are two variants of polar biphase schemes. The first one is Manchester. Students, Manchester scheme essentially combines the return to zero and non-return to zero level schemes. Similarly, our differential Manchester combines return to zero and non-return to zero invert schemes. Students, in the first case, which is the case of Manchester coding, you can see that the duration of the bit is divided into two halves this time. The voltage remains at one level during the first half and it moves to the other level in the second half. So, in the first half, starting from the positive voltage, for a zero we start from positive, make a transition to the negative voltage directly and finish here. Now the next bit is 1. We start from the negative voltage, make a transition to the positive voltage in the middle of the bit and finish at the end of the bit. Next bit again is a 0. We start, make a transition, finish here. The next bit is 0 again, so we cannot start from the negative voltage. We make a transition all the way to the positive one and start here, and then the next bit is 1. We carry on. The next bit is 1 again, so we come back to the negative voltage and we carry on. Students, before we discuss the advantages and disadvantages of these two, the biphase techniques, let's discuss differential Manchester as well. As I told you, differential Manchester combines the return to zero and non-return to zero invert. So, in this particular case, this makes a transition, the scheme makes a transition in the middle of the bit, as you can see here, but it also follows the NRZI principle, which means that there is no inversion if the next bit is 1 and there is an inversion if the next bit is 0. So students, in the case of 0, we start from a positive voltage level, we start from a negative voltage level, make a transition in the middle and then finish here. Now the next bit is 1, so there will be no change. We go, make a transition and finish here. Now the next bit is 0, so we go up, start from the positive level, make a transition and then finish here. Next bit again is 0. So we need to invert, go up, make a transition, come down. Next bit is 1. So there is going to be no inversion straight away. Make a transition, finish here. Next bit is 1 again. So no inversion. We go straight and finish here. Now students, in this particular case, the Manchester scheme, for example, it overcomes quite a few problems that we had with the NRZL, and the differential Manchester, it overcomes quite a few problems that we had with NRZ invert. Firstly, the major problem that we had of DC component, that DC component problem does not exist in this particular case because each bit has a positive and a negative voltage level. Students, the only disadvantage that we have for these two techniques is the signal rate. And the reason signal rate is a problem is because the signal rate for these two, Manchester and both differential Manchester, it is actually double that for the NRZ schemes. And the reason for that, as you can see clearly in this slide, is that there is always one transition at the middle of the bit, and then depending upon the inversion, there can be a transition at the end of the bit as well.